Hi. In this video I'd like to show you basic techniques to design primers. So let's get started. Before we begin, let's review the basics of PCR. In general, in PCR you're given one sequence to amplify, which is usually given from 5' to 3'. Guys, can you play something softer? That's better. So where were we? In reality, there's a second sequence in the tube, which is annealed to the first in the opposite orientation. The first thing that happens in the reaction is that the two strands get separated. So after the heating step, it looks a little bit like this. Both strands are still present in the same orientation as before, but they are now separated. The next thing that happens is primer annealing. The first primer anneals here on the bottom strand in the opposite orientation of the strand. The second primer anneals there on the top strand, also in the opposite orientation of the strand. Then elongation can proceed. The primers are elongated in the 3' direction, so elongation produces another copy of the top strand and the bottom strand. Let's now have a look at a concrete example. Let's say that we have to amplify a sequence that consists of a bunch of A's here followed by a bunch of C's. The first thing that we do is that we make sure that we specify where is 5' and where is 3'. The second thing is that we remind ourselves that there exists in the tube a second sequence that is the reverse complementary of the one that we were given. So we write a bunch of T's annealing to the A's and a bunch of G's that anneal to the C's. And importantly, we make sure that we specify where is 5' and where is 3', so that we do not get confused later on. Next, we remember that we have to design a primer here that anneals on the bottom strand in the opposite direction, with the 5' on the left and the 3' on the right. Looking at this, we see that the primer consists of a series of A's that will anneal with the T's on the bottom primer. We also have the orientation here in the arrow with the 5' on the left and the 3' on the right. Next, we design a primer that will anneal on the top strand, here with the opposite orientation of the top strand, with the 5' on the right and the 3' on the left. Looking at this, we see that the primer consists of a sequence of G's that will anneal with the C's in the top strand. And again, we have the 5' in the direction of the arrow, which is on the right, and the 3' on the left. And that's it, we're done. The first primer consists of a sequence of A's that will anneal to the bottom strand, and the second primer consists of a sequence of G's that will anneal to the top strand. As usual, we have to give the sequences from 5' to 3', so we take care of specifying the orientation on the sequences, and the primers are ready. Let's give a final example that will be more realistic. Let's say that we have to amplify that sequence here by PCR. As usual, the first thing is to label the ends. We start by specifying that this here on the left is the 5' end, and this on the right is the 3'. The parts in the middle are not really important because the primers won't anneal there. The next step is to write the reverse complementary of the sequence that we were given, and also to label the ends, just so that we don't get confused later on. We next design our first primer, the one that will anneal here at the bottom strand in this direction. We label the arrow here with 5' and 3'. Based on what we see, it is now easy to design a sequence that is the reverse complement of the sequence that we see appearing in the bottom strand. We label the ends, 5' on the left and 3' on the right, just like in the arrow above. We are now ready to do the same thing on the top strand, so we start by drawing the arrow that will indicate where is the 5' end and where is the 3' end for this primer. Based on what we see, it is now easy to design a sequence that's the reverse complement of the sequence appearing on the top strand. And again, we label the ends with a 5' on the right and the 3' on the left, just like on the arrow above. And that's it, the sequence of the primers already appears on the sketch. For the bottom strand, the sequence is indicated here, and it goes directly from 5' to 3'. For the top strand, the sequence is indicated here, but it goes from 3' to 5'. So one last thing that we need to do before submitting our primers is that we need to reverse the sequence, so that is now given from 5' to 3'. Note that we're not reverse complementing the sequence, we're just reading from right to left because this is already the sequence that we need. So that gives us 5', and then C, T, A, C, C, etc. and so on until the very end, which is T, A, C, and 3'. And that's it. This is the final sequence. This one we don't need because it's indicated in the wrong direction. So our final answer is that it's this sequence here that will be the primer for the top strand.